What's up guys? Matt here again from the Maths Hero, and this is your essential guide to everything you need to know for your Year 5 maths, okay? If you can master these skills, you are going to become very successful in all of your maths area because these are the fundamentals. And if you can get these in your head and really understand these, you're going to become very successful, okay? So let's show you what you're going to be looking at. You're going to start with addition, then you're going to move on to subtraction, multiplication and division. There are 4 corners of maths, okay? So this is going to show you what you need to know for your Year 5 in those areas. Then we're going to look at fractions, adding and subtracting fractions, then looking at perimeter, and finally, the challenging one, we're going to be looking at starting algebra and understanding what algebra is, okay? So let's waste no time, let's get straight into our first lesson, which is addition. Okay, before we can do anything, what is a multi-digit? Well, a multi-digit is any number that's got more than one digit place. So 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all single digit numbers. Anything above that, 10, 11, 12, all multi-digit. The number 19, double digit. We've got a 1 and a 9. A 9 in our units, a 1 in our tens. If we look at a great big number, 25,423, that's a 5-digit number because we've got 5 digits going along our place value chart. Okay, so with that in mind, let's move on. Our first question, 333 and 651. Now we are going to be perfect mathematicians today and we're going to set our work out beautifully to avoid making any small mistakes. So the first thing we always do when looking at anything in column method, we always set out our work neatly. So let's do it. Units, tens and hundred, put our equals bar across, our add sign for good measure to remind ourselves we are adding today, and we are good to go. Now, if any of you have watched any of my other videos, I think it's a great tip to bring this top bar down because we are going to be using that column potentially, that row potentially later. But wait! Does it matter which way round we put these numbers in our question? If we add 333 to 621, do we get the same as adding 621 to 333? Let's pause a second and let's look at it in this scenario. If I have 11 add 4, we get 15. I can represent it here with these images. If I switch these around and add 4 add 11, I still get 15. And that is because addition is commutative. It doesn't matter which way around we put our question, we're going to get the same answer. Let's go back. Okay, so we are ready to begin. Where do we begin? Well, we always start at our smallest value. And in this case, we've got a 3 and a 1 in our units column. So we are going to use our basic addition facts, and we're going to simply add them up. 3 add 1 is 4, so we just drop it into our equals bar. 4 units. Next, we've got 3 and a 2. 3 tens adding to 2 tens. A 30 at a 20 gives us 5 tens. Okay, good. Our tens column complete. Last but not least, we go into our hundreds column where we've got a 3 representing 300 and a 6 representing 600. Add the 2 together, we have 9 to complete our answer. Drag it up to the top. So 333 add 621 is 954. Easy, yes? Well, the observant ones will see a little green chili in the corner. This was a very mild question. Stage 1 I like to call it, or a green chili challenge. Okay, so let's have a look now at a yellow chili challenge. Let's see how this can get a little bit harder, okay? Let's have a look at the number 434 at 881. Now, same thing, we're gonna lay out our columns exactly as we should, put all our things in place, our units, tens and hundreds, our addition sign, and our equals bar, okay? Perfect, we are looking good. Remember, let's drop that bar down so that it gives us that spare row. We're gonna see how we're gonna use it in this question, okay? Where do we start? Well, we know now we start in our units column. We always start in our smallest value whenever we're doing any form of column work, addition, subtraction, multiplication, anything like that. We always start with our smallest value. So here we go. Let's start with our smallest value. Our units, adding 4 to 1 equals 5. Nothing difficult there. Same as stage 1, same as our green chili challenge. Next question, 3 add 8. Okay, we have 3 and 8. 3 add 8 is 11. So we have a difference here. If we were to put 11 straight into our answer bar, we would be taking the place of our hundreds already, and we haven't added our hundreds yet. So we need to think about what this all represents and what we're going to do with this number. So we've got 11 tens, or we could look at it as 110 as the answer to this bit of our question. So we're going to use what we know of place value, that we haven't yet added our hundreds yet, and we're going to add this 1 into that column in that spare row, waiting for our hundreds question, okay? Which means we're going to add our 110 in our tens column in our answer section. But we haven't yet done our hundreds, so we're going to put this 100 up there, okay, waiting. Now we can answer our hundreds. I've got a 4, an 8 and a 1. Add them all together, gives me 13. So again, gives me a 2-digit answer. But different again, we have no further question. We don't have a 1,000 column ready, so we can just put our full answer in there. Put the 13 straight into our answer. A 1 in our 1,000, a 3 in our 100, leaves us with a grand total of 1,315. The answer to 434 add 881 is 1,315. This is called regrouping or bridging, depending on where in the world you're from. It means the same thing. We are just moving our number digits into the next column when we need to. We understand that if we were to add an 8 and a 7, we get 15, which is a 10 and a 5. So we can move that 10 into the next column waiting for us, okay? So very straightforward. It just takes a little bit of thinking. If you are struggling with it and you think, whoa, this is brand new to me, I've never seen anything like this before, rewind the video, have a little look at this question one more time, okay, before we move on to our red chili challenge. Okay, red chili challenge. Now you might be thinking, Mr. Maths Hero, this looks easy. This looks just like a stage 2 question, but it's not. We have got different amounts of digits in our question. We've got 962, which is a 3-digit number, and we have got 89, which is a 2-digit number. Now I cannot tell you how many times I have seen this mistake where children or adults even put these in the wrong column. So we need to understand place value again. You are going to get sick of me saying place value, but it is very, very important. So we need to understand what the value of these numbers are and where to put them. If I was to put my numbers over here and line them up like this, I have changed the whole value of our 89. And I have actually turned our number, using our placeholder here to represent where we've left a gap, we've turned it into 890. We've completely changed the question, so we are going to obviously get the wrong answer. So, what does our number represent? 89 is 8 tens, 9 units. Let's just put it in like that. 9 units, 8 tens. We know we're not going to make any mistakes. Now, we do have a gap here. We can put a placeholder, or you can leave a gap. It's up to you if you know that that's a gap there, or if you know that there's a 0 representing that. It doesn't change the value. Whichever you're more comfortable with is fine by me, okay? I'm going to put this little half 0 there so you can see it there or not there. Okay, let's start again. Same as before, we're going to start our units column. 2 add 9 is 11. 1 unit, 110, waiting for us for that next question. Tens column, a 6 and an 8 plus this 1 equals 15. Remember, 5 in our tens column, 1 now goes into our hundreds column. Looking at our hundreds column, I've got 9 and a 1. 9 and 1 equals 10. I've got no further questions to ask, so we just write the 10 straight in there. 1051, 1051. Okay, a few little differences there. We had 2 bridging or 2 groupings in a row, and we had this placeholder to consider and not make a mistake by putting things in the wrong line. This is about as hard as it's going to get. Red chili challenge. If you can do this, you can pretty much master column addition with multi-digit numbers, okay? And that's great. Right, if you are up for it, I have got a mega challenge here for you. This is a really hard question, and this is as hard as it could possibly get. Now, I've got 3 numbers here. That's a little bit different, but it's not harder. It just means we've got 1 extra row to add up. Okay, so have a little go at that. If you need to, press pause. I'm going to flash the answer up in 5, 4, 3, 2, 1. Answer. Okay, so 4,211 add 901 add 591 equals 5,703. So I had to squint. I wrote that really small on the wall over there. I couldn't remember it. Okay, well done. If you got that right, you have mastered this lesson. Well done. Very, very well done, and I'm proud of you all. Okay, so as always, I'm going to tell you where your journey is going to take you, where your learning journey is going to take you, what is coming next, your next step. Okay, today we have been looking at whole numbers, a 3-digit number adding to a 2-digit number or another 3-digit number, but they are whole numbers. Your next step, you're going to be looking at decimals. So if you are there, if you've mastered this lesson and you want to move straight onto that, check out our video which is on our channel, or if you want to master this a little bit, practice this video a couple of times, go through some practice questions before you feel like you're ready to move on. Okay, one very important thing we must discuss before we begin, and that is the law of commutativity. A horrible word, but it's not as hard as it sounds, okay? It just means, can we put our numbers in different places in our number sentence? So, with addition and multiplication, those numbers and those operations are commutative. We can put them in any way. So if I show you this, if we have 15 add 6, I get 21. If I have 6 and 15, I also get 21, but I've moved the two numbers at the beginning around. Okay? Now if we look at that in terms of subtraction, if I have 15 subtract 6, I get 9. But I can't get the same answer by moving my numbers around. They are not commutative. If I have 6 take away 15, 6 subtract 15, I get myself in all sorts of trouble we don't really want to talk about yet. But I know I don't get the same answer, okay? These numbers are not commutative. What does that mean? It means we've got to be ultra careful in the way we present our work and in our setup, okay? So let's have a look at a bigger number and what I'm talking about. So let's start at this. Let's have a look at a green chili challenge. Let's have a look at 149 subtract 26. So the question is saying, I've got 149 something. I could have vegetables, cars, money, whatever. 149 subtract 26. I'm subtracting 26 away from our original number 149. I can't manipulate that. I can't change the question. I can't say 26 subtract 149. That's not the same thing. So we need to be ultra careful in our layout. So first things first, let's arrange our columns. And you will know if you've seen any of my other videos, it's very important we put our units, our tens and our hundreds, our column titles at the top there to remind us to stay in our columns and be neat and organized. So hopefully we're pretty confident with our place value. If you're not, check out our place value videos, get all the information you need on that. But I know that I'm going to put my units in my units column, my 9 and my 6 in my units. I'm going to put them in my units column. But which way around do I put them? Do I put my 149 on top? Do I put my 26 on top? What do I do? The best tip I can give you, write it as you read it. It says 149, take away 26. So I'm going to write 149, subtract 26. Okay, I'm writing it as I read it. Some people might tell you, put the biggest number on top. I don't really like that piece of advice. There are questions which our answer needs to be negative, so we can't always put our bigger number on the top. We have to put our number on the top, which comes first. If it says 149, subtract 26, it means 149, subtract 26. So where are we going to begin? Well, you should know now we are always starting with our smallest value. In this case, we have units as our smallest value, so I'm going to start there. 9 subtract 6 gives me 3. Put my 3 in my answer row. Move across to our tens column. 4 subtract 2 gives me 2. 2 in my answer row. Move across, last time, look at my hundreds column. I've got 100, subtract, nothing there, or a 0, 0, 26. So 1 subtract nothing is 1. My answer, 123. 149 subtract 26, 123. Okay, don't forget to always pull your answer up to your number sentence to complete your question. Boom! Green chili challenge complete. Let's move on to red chili challenge. Red chili challenge. 123 subtract 15. Now you are thinking to yourself, I can read your mind, you are thinking, yo, that is just as easy as before. Well, let's check it out, okay? Let's put it back into our columns like we know how to now. 123, subtract 15. I've written it out perfectly. Draw my answer lines. Fantastic. Okay, now let's begin. I'm going to start at my smallest value, the units value. 3 subtract 5. Boom! Stop there. What does that mean? I've got 3. How am I possibly going to take away 5? Imagine you have 3 pencils in your hand. You can't take away 5. So what are you going to do? We need a method. We need a strategy. Okay, now this is where your understanding of place value is really essential. We should know that if we look next door, we have our tens column. So if we look in our tens column at this number 123, I have 2 tens. So I can look at my 2 tens as 2 tens, or I can look at it as a 20. And now I'm wanting to borrow or regroup from that number because my little weeny little 3 is not big enough to take my 5 away from. So I need to borrow something. I'm going to borrow from my neighbor next door. So we're going to go knocking. We're going to look at what we've got next door. I've got 2 tens. So I don't need 2 tens. I don't need the 20. I'm only going to borrow 1 10. Okay, 1 10 being a value of 10. So I'm going to borrow that, put it next to my 3. 10 and 3 equals 13. So my new value in my units column is actually 13. Now what I must remember to do at this point is I must remember that I've taken away one of the tens from my tens column. So this is no longer a 2, this is now a 1. Okay, good, I'm ready to continue. 13, subtract 5 is 8. Beautiful. Move across to my tens column. 2, subtract 1. No. 1, subtract 1. Remember, we took that digit away. We used that 10. So now I only have 1 10 remaining. 10, take away a 10, leaves me with no 10s. Good, moving over to my hundreds column. 1, subtract 0 again is 1, leaving me an answer of 108. Now let's remember, we always finish our number sentences, drag it up. 123, subtract 15 is 108. You've just done a red chili challenge. Okay, let's take this time. I'm going to throw 3 questions on here. I'd like you to stop, pause the video, take some time to have a look at these, see if you get them right. If you get them right, great. If you don't, go back, rewind the video and see where you might have made a small mistake. Okay, press pause. I'm going to come back to you in 5, 4, 3, 2, 1, boom. Okay, good, I'm back. So, throw the answers on the board. See how you got on. Hopefully you got them all right. If you did, great. You have just mastered this lesson. If not, don't sweat it. Go back, check it out, see where you might have made a mistake, correct it, and have another go. Okay? So let's just recap the important aspects of this lesson. Firstly, the layout is really important, not just to remember your column titles this time, but also the order you write your question. Remember, you write it as you read it. It's a good tip. Remember it. Next, presentation. Presentation. Okay, maths is all about organizing and being neat and avoiding those small mistakes. So make sure you're writing nice and neat in those columns. Last but not least, we start at our smallest value and we borrow from our next column along, our bigger value next to us, if we need to, okay? What's up guys, welcome back. I've got a brand new video. Today we are looking at multi-digit multiplication. So that is a multiple digit multiplied by a multiple digit. Okay, this is pretty high-end stuff, so check it out. Right, first, what is a multi-digit? Well, a multi-digit is any number greater than 9. So for example, 10, 11, 53, these are all multi-digit because they have more than one digit. Okay, the number 4 is just a single digit because it's just one digit on its own. And we can go all the way from 10 to infinity, will all be multi-digit numbers because they're all going to have multiple digits going along the place value chart. Okay, so that's very important to understand before we start. The reason that place value is so important to understand before we start is because we're going to use our understanding of place value to partition and break up our multiple digit so that it's back into more manageable chunks that are easier for us to multiply. But before we get into it, let's review what we've done so far in previous videos to understand where we're at now, okay? So our written method started with grid method. Now grid method was really useful because it really showed us what we're doing. We're breaking up those numbers and we're answering them in smaller chunks and then putting that number back at the end to give us our final total. Okay, so that was the start, but it was a bit long. We realised that when we got into bigger numbers, it got a bit long and a little bit laborious. So then we moved into formal written method, which is our columns. Okay, but we looked first at expanded method, which was a bit like grid method, but looking at it in the formal written method. So we still partitioned every part, and we still wrote down each individual question and did them in 4 or 5 different rows. Okay? Again, a good method for understanding our cognitive understanding and our understanding of what's happening, but it was a bit long. And our method after that still looked at multiple digit multiplied by a single digit, and we did it quicker using a similar method to, say, addition or subtraction, where we stayed on one row to answer each individual part. So if we were looking at 32 times 5, that first row would have 5 times 32 all in the first row, rather than having a second row for 5 times 2 and then the second row for 5 times 3. Okay? That was another step forward, but now we're at our ultimate step. We're going to add a multi-digit to the second part too, so it's going to be a multi-digit times a multi-digit, okay? It is a leg up, it is our next progression, and there is a little trick to it, something that we need to learn and something that we need to understand, okay? So, let's start. Let's have a look at a green chili challenge. So let's use the example 32 times 25. We're going to start at our smallest value, but it's really important to understand what we're doing. Our first row is actually going to use this unit here times by 32, so it's going to be 5 times 32. And our second row, our last row, is going to be 20, which is what this 2 represents, 20 times 32. And we're going to add them together. So we're still partitioning it, but we're doing it a little more discreetly. And if we're not exactly sure what we're doing, we might make small mistakes, which is why it's really important at this stage to really understand exactly what we're doing and where our numbers and answers are coming from, rather than just following a process. So let's start together. Let's do 5 times 2. Well, 5 times 2 is 10. So let's put our 10 in, as we would do now if we were doing, say, for example, an addition or subtraction question at our shortest method. So I'm going to put my 1 into my tens column as a small little 1, just so I can remember to add it to my tens column when I do that, but I'm going to put my 0 in my units column. Now I can move on to my second part of the question, 5 times 3. Well, 5 times 3 is 15. I've got no hundred, so I can just put the answer straight in there, but I must remember to add on that 1 that I had in my tens column from before. So 15 plus 1 is 16. So the answer to 5 times 32 is 160. Okay? So, good. We've done that first row. Now I'm going to do 20 times 32, but I don't want to look at it as a 20, and here's the thing that's going to get tricky. Okay? Here's the thing that we need to understand. Here's the difference between this method and our previous method in terms of how hard it is. Okay, so we're going to include what's called a placeholder, because we want this whole question to be 10 times smaller to work with. We don't want to work with 20 times 32, we're going to still do 2 times 32. And to make it 2 times 32, we're going to make our answer 10 times larger, because we know it's not a 2, it's actually a 20. So let's make our answer 10 times larger by putting a placeholder. I'm sure you've all done this, but you might not be sure why. Okay, so we're putting this placeholder in there because if we do 2 times 32, we need our answer to actually be 10 times larger than that. Okay, so put this placeholder in there. Now I can treat it like 2 times 32 again. 2 times 2 is 4. Put my 4 in the next available column, which is my tens column. And again, this is where some people might make mistakes, because they think, well, I've just put my 0 in my units column, but I always meant to put my answer in my units column. Well, that 0 is holding the place of the units, okay, because we're 10 times larger. So our next space is tens. 2 times 2 is 4. And we can check that because 2 times 20 is 40. And that's what it said. Cool, we know we're doing something right. Okay, so the next part says 2 times 3, which is 6. Put that in there, 640. Are we finished? No. Anyone who's done partitioning before knows we've only done the individual elements. Now we're going to put it back together. Again, starting our units, 0 and 0 is 0. 6 and 4 is 10. Remember to move the 1 across. 1 and 6 is 7, plus the 1, 8. 800, okay? 32 times 25 is 800, and that's a green chili challenge. Okay, let's look at an orange chili challenge. Now at this point, I want to highlight something. I want to talk to you about something, an expression we're going to use quite a lot, and that is it harder or is it just longer? Okay, now in this example for the orange chili challenge, I pose to you that it's actually just a little bit longer. This isn't harder, what I'm about to show you, but it's just a little bit longer. And I've given it an orange chili because the only thing we need to understand today really is why this is only longer and not harder. So I've given it orange, although it is actually still probably only a green challenge. Okay, so let's have a look at it. It's 482 times 24. Okay, now let's think back to our understanding of what we're doing. We are breaking this number down into more manageable chunks. So we're going to isolate those two numbers again on the bottom row, and we're going to break it up and we're going to multiply the top row by it in little chunks. Okay, so my 4 is going to times 482 first, which is going to make that first row, and my second row is going to be 20 times 482. Okay, but remember, we're going to add that placeholder to make it 10 times larger, so we can just do 2 times 482. Okay, so this is only longer because we've only added a digit to the top line. And we're going to see what happens when we add a digit to the bottom line in a moment. But let's answer this challenge first of all then. So 482 times 24. Start at our smallest value, and we're going to start with the 4 times 2. 4 times 2 is 8. Then we're going to move across. 4 times 8. 4 times 8 is 32. Add 3 across into my hundreds column and 2 into my tens. Good. 4 times 4 is 16. Add the 3, 19. So my answer to 482 times 4 is 1928 and completes that first row. Now my next question is 20 times 482. So we don't like 20, so let's make it 10 times smaller and put it as a 2. But that means we need to make our answer 10 times larger so we actually get the correct answer. So I'm going to put my placeholder in place. Okay, great. Now it's just going to be 2 times 482. So 2 times 2 is 4, add that in. 2 times 8 is 16, put the 1 across, put my 6 in place, good. 2 times 4 is 8, plus the 1, 9. 9,640. Now here's something really important. Look at these extra numbers that we've got in here. These were helping us solve previous parts of the question. And we should have put a line through them when we're finished with them, okay, like I have. And we must remember at this point we do not add it to our total because those numbers have already been used and we've already got them added to whatever we needed them for, okay? So we don't want to add them again now, so let's make sure we don't do that, guys. That's really, really important, a top tip. Okay, and remember, add it together, so put my line across, make sure I add it. 8 add 0 is 8, 2 add 4 is 6, 9 add 6 is 15, move my 1 across, put my 5 in place, and then 1 add 9 is 10, plus the 1 is 11. 11,568, and that is your orange chili challenge done. Okay, final stage, our red chili challenge. Now we are going to make this harder this time because there's an extra element we need to understand, okay? So I'm going to give us the question, 452 times 235. Now these are huge numbers now, so we've got to be really careful and we've got to be really precise. So we're going to carry on like we did before, and we're going to understand that we're going to partition it all, okay? So all we're doing for this first line, for this first row, is we're still multiplying 5 by 452. Okay, so 5 times 2 is 10, good. 5 times 5 is 25, add the 1 is 26. 5 times 4 is 20, add the 2 is 22. So our first row, 5 times 462, is 2,260. Okay, right, now our second row, same as before, we are now looking at this 3, but it's not a 3, it's a 30, so let's make it 10 times larger by putting in our placeholder, okay, because it's a 30. It's 10 times larger than 3, which is what we want to be dealing with. Okay, so just like before, 3 times 2 is 6, 3 times 5 is 15, 3 times 4 is 12, plus the 1, 13. So 30 times 462 is 13,560. Okay, great. Now, we've got an extra number. We've got this 2, this 200 here, okay? Now we want to do just like before and multiply it by the top row, so we're going to do 200 times 452, but I need to think about my placeholders because I can't just put one placeholder because that would mean the 2 actually turns to a 20. But it's not a 20, it's a 200. It's in our hundreds column. So I need, that's right, 2 placeholders, okay? Because 200 is 100 times larger than 2, the number we're actually going to be multiplying with. Okay, so I need to put 2 placeholders in now. Now we can just carry on like before. 2 times 2 is 4, making sure I put it in the correct column because I've now got 2 placeholders occupying the units and the tens column, so I'm going to put this straight into the hundreds column. So 2 times 2 is 4, and I can check that because 200 times 2 is 400. Okay, great. 2 times 5 is 10, so we've got a 1 across and put our 0 in the right place, and 2 times 4 is 8, add the 1 is 9. Okay, great, we've just done our third row. Okay, let's make sure we add it up. So 0 plus 0 plus 0 is 0, obviously. 6 plus 6 is 12, making sure not to include that other 1. 2 plus 5 plus 4 plus that 1 is another 12. And then 2 plus 3, add the spare 1 is 6. 1 plus 9 is 10. So we get 106,220. Now, anything beyond this level is just going to be longer. Now we could have a 4-digit number multiplied by a 4-digit number, and all that's going to do is add another row where we need to add 3 placeholders because we're looking at thousands now. We could look at a million times a million if we wanted to, okay? It's not going to make it any harder, it's just going to make it longer. But don't forget, sometimes when we do things longer, we might make mistakes. So it's really important that we check our work and are really, really careful, okay guys? Well done. So let's recap some really important things from today, guys. First of all, it's really important to put our layout and our numbers in the correct columns. This is really, really important today because we've got such a huge amount of numbers that we're going to be multiplying, and when you get into 4-digit numbers or 5-digit numbers and anything like that, you actually get a really big area where your answer is, and it comes out like a triangle formation as the number gets bigger and bigger. So if you're not in the right columns, it can look really messy and almost be impossible to make sure at the end when you're trying to add up, you're adding up the correct columns. So organisation and layout is really important. The second thing to understand is knowledge of partitioning and knowledge of place value. Understanding that when we're timesing 32 by 25, we can break it down into those smaller chunks and understand what chunks we are actually multiplying at the time. Okay? Next thing to remember is our placeholders. Placeholders are hugely important to understand, not just to do, but to understand, okay? We need to understand what we're doing. If we're doing 25 times 32, and we've got the 32 on the top and the 25 underneath, then we need to understand that when we come over to that 2 part and we're timesing the 2 by 32, then it's not a 2, it's a 20. Okay, we're only wanting it to be a 2 because 2 is easier to multiply. Okay, so if we are making it a 2, we've actually made it 10 times smaller. Okay, so when we make our answer, we need our answer to actually be 10 times larger, what it's supposed to be. Okay, so placeholders are really important to understand. And the final thing, final recap, make sure that when we've done our answer, we don't just finish with the partitioned answer, we actually add it together to give us our grand total, because that's what we're looking for. We're not looking for the partition numbers, we're looking for that grand total. Okay, well done. Right, I'm going to put some questions for you on the board here, guys. I'm going to put 4 questions. There's a green, an orange, and a red. So challenge yourself. If you get all 4 of these right, you are ready for our next step, and that is multiplying decimals. That is our next step, our next progression in our understanding of multiplying. Right, before we can start, we need to think about what division actually means. Well, if I pull this question up, 12 divided by 3, we will learn that we can talk about division in 2 different ways. We can talk about it as sharing. If I have 12 lollipops, I can share them evenly between my 3 friends, giving them a total of 4 each. So 12 divided by 3, 12 shared by 3 is 4. Or I can look at it as grouping. How many groups of 3 are there in 12? That's a slightly more advanced level. Well, let's have a think. There's 1 group of 3 and 3, 2 groups of 3 and 6, 3 groups of 3 and 9, and 4 groups of 3 in 12. So we can look at it in 2 different ways, sharing and grouping. Now, the reason that a question like 12 divided by 3 is quite straightforward is because 12 divided by 3 is part of a number family. 12 divided by 3 is 4, and 4 times 3 is 12. They are in the number families. But what happens if these questions get a little bit harder and they're not in number families? Let's have a question like 14 divided by 3. Well, we can try and share them. I've got my 14 lollipops and my 3 friends. I'm going to share them evenly. Gives them 4 each again with these 2 left over. Now, these 2 left over are very important. I cannot share them evenly between my friends, so we have to leave it as a remainder. So 14 divided by 3 would be 4 remainder 2. If I try that with grouping, it would be the same thing. 3, 6, 9, 12, 4 even groups, and 2 left over. Okay, 2 remaining. Okay, now that's pretty straightforward with small numbers. We can easily share our lollipops out. Might take a little while, but we can do it. And I can group because I know my times tables, okay? But what happens if we get a bigger question? Let's have a look at a green chili challenge. Let's have a look at 248 divided by 2. Now, I don't want to share out 248 lollipops. That's going to take me all day. And I don't want to have to go over my 2 times table all the way to 248. Again, that's going to take me a long time. So we need another method. This method is called the bus stop method. Now, we call it the bus stop because it looks a little bit like a bus stop. Now, we need to know, before we can start, we need to know where we are going to put our features, our parts of our question. So I'm going to put the dividend, which is the big number, the number we are trying to break up and share. I'm going to put that inside the bus stop. So I'm going to put my 248 inside my bus stop. Now I'm going to put my divisor on the outside, the small number, the one we are sharing the bigger number into. Okay, so my question now looks like this. How many 2's are there in 248? Okay, now before we can start actually solving this, let's think about our layout again. Let's put our hundreds, tens and units in to help us just understand what actually is happening, okay? Because we are going to start dividing along our bus stop, but I want us to understand exactly where our numbers are coming from and the actual real true value of our answer, okay? So, if we're going to look at this first part, 2 divided by 2, how many 2's are there in 2? Let's share it out. How many 2's are there in 2? Well, it's 1. We can share it evenly once. Okay, so how many 2's are there in 2? There are 1. Okay, but the question actually said, how many 2's are there in 200? And the answer is actually 100. Okay, so let's just keep that in the back of our minds just for our own understanding, okay? Now, the second part, how many 2's are there in 4? Well, if I share 4 between 2 people, I give them 2 each. So my answer for that section is 2. Last bit, how many 2's are there in 8? Well, the answer is 4, giving me a grand total of 124. Let's drag that back up to complete our question. 248 divided by 2 is 124. Great, green chili challenge, done. Okay, let's have a look where this can go. Let's have a look at a red chili challenge because they're not always going to be as easy as that. We could get complications as we're going to see now, okay? Let's have a look at 896 divided by 5. We're going to put our hundreds, tens and units up there just for our own understanding, but we're going to start in the same way. How many 5's are in 8? Okay, now let's go in our 5 times table. 5, 10. So we can't have 10. We've got one lot of 5, but then we've got 3 left over. Okay, let's have a look at that in sharing. If I have 8 and I try and share it evenly between 5, I give them all 1, but I've got 3 left over. Now I can't ignore this 3. I'm going to move it over into my next column and make my 9 a 39, okay? Because that 3 is actually worth 3 10s, okay? That's why it's good to understand our columns. Okay, let's look at my second part then. So how many 5's are there in 39? Let's go up in our 5 times table. 5, 10, 15, 20, 25, 30, 35, 40. I can't use 40 because it's over 39, so let's come back. 35 goes 7 times. So I'm going to put 7 at the top there. But what have I got remaining? I've got 4 remaining. Okay, so I'm going to bring that 4 over into my next column. Okay, last bit says how many 5's are there in 46? Again, let's do the same thing. 5, 10, 15, 20, 25, 30, 35, 40, 45. Can't go to 50, so I've got 9. What's the difference between 45 and 46? I've got 1 left over. So my answer is 179, remainder 1. 896 divided by 5 is 179, remainder 1. Okay, that's about as hard as short division you can go. That is a red chili challenge. So I'm going to put these 3 questions up on the board. Take your time, have a little go at them. Put your answers in the comments section below. Let's see if you get them right. If you do, fantastic, let's move on. If not, take a little bit of time on this video and make sure you fully understand it before moving into our next video. Okay, so I'm going to put the answers up in 5, 4, 3, 2, 1. Okay, answers on the board, fantastic. Well done if you got them right. As I say, let's move into our next video then. If not, rewind, go back, see where you might have made a mistake and correct yourself, okay? It's all about making sure you've got a great understanding before moving into our next step. So what is our next step? We have been looking at short division today. A multi-digit number divided by a single-digit number. Well, long division, our next step is going to be looking at a multi-digit number divided by a multi-digit number. Okay, so if you're ready for that, check out our next video. Okay, so we are going to be looking at the basics of adding and subtracting fractions today. Now, if you've looked at multiplying fractions already, great. If not, don't worry. I personally think that looking at multiplying fractions before you're looking at adding and subtracting fractions is a good piece of advice. So check out our video on multiplying fractions if you haven't already, okay? But today we're looking at adding and subtracting fractions. So if you have looked at multiplying fractions, you will know that it's very simple. All we do is we multiply the top numbers and we multiply the bottom numbers. So if we have 3/5 multiplied by 2/4, then all we need to do is multiply the top numbers. 3 times 2 is 6. Bottom numbers, 5 times 4 is 20, giving our total of 6/20. But can we use that same trick for adding and subtracting fractions? Let's have a look. Let's have a look at a really basic fraction. Let's have a look at 1/2 add 1/2. Now we know that's going to be a whole. 1/2 of pizza and another half of a pizza is going to give you a whole pizza. Okay, so let's just see if that same tactic works for this. 1 add 1, looking at the top two numbers, equals 2. If we look at the bottom two numbers, 2 add 2 is 4. Now 2/4 or 2/4 simplified down is 1/2. 1/2 add 1/2 is 1/2. Okay, we've done something wrong. We cannot use this same trick. Okay, let's see why this does not work. We have a very important rule in mathematics, and that rule is something called the order of operations. Okay, now what that says in this rule is that we need to always multiply and divide before we add and subtract in any problem. And because fractions are just division problems, we can't do the addition before we do the division part, okay? So we can't add the top numbers and then the bottom numbers, because then we're skipping out the division part, okay? And we can't do that. Okay, so luckily we do have another trick. This is your secret tip. Don't tell anyone. Okay, but before I can tell you the trick, we need to look at a fraction and what it's made up of, okay? We have a numerator at the top and a denominator at the bottom. Our denominator at the bottom just is the name of our fraction. It's 1/5, 3/5, 5/5. It's a fifth. The value is fifth, okay? The numerator is how many fifths, the number, the quantity, how many fifths we have. 1/5, 3/5, 4/5. How many of that value do we have? Once we can understand that, once we can start to think of a numerator as the number, the volume, the quantity of the fractions we have, similar to saying 1 donkey, 3 donkeys, 5 donkeys. It's just the name of the fraction. So if we think of it like that, the numerator is how many we have and the denominator is what the name is, then we can just simply add the numerators or subtract the numerators to give us our new value. Okay, so if we look at that with our halves again, we have 1/2 add 1/2. So we're going to add our numerators. 1 add 1 is 2, but we're going to keep our denominator, the name, the same because the value of our fractions haven't changed. Okay, so 1/2 add 1/2 is 2 at the top, 2 at the bottom is a whole. Okay, then that's right. 1/2 add 1/2 is a whole. Fantastic. Let's see another example of this trick. If we had 3/15 add 4/15, we could have 3 elephants, add 4 elephants. 3 add 4 is 7. The name of the fraction hasn't changed, it's a 15th, so we have 7/15. Simple. And the good news, that works with subtraction as well. Let's have a look. If we have 5/10, subtract 2/10, what am I doing? I'm taking 2 away from the 5. 5 subtract 2 is 3. We haven't changed the value of the fraction, so we have 3/10. Simple. How easy could this be? Well, let's just pause a second. Let's not get carried away. Let's not think we are Albert Einstein all of a sudden, okay? We have got a little problem. All of our denominators are the same in these examples, okay? We had 1/2 add 1/2, 3/15 add 4/15, 5/10 take away or subtract 2/10. Now the name for this is like fractions. They are alike. We have 1/2 add 1/2. We had 3/15 add 4/15. They are alike. If the denominators are the same, we call them like fractions. And if they are not alike, we call them unlike fractions. Okay, and we need a solution to adding unlike fractions. But don't worry, I would never let you down like that. There is a solution. We can manipulate the look of our fraction, give ourselves an equivalent fraction, but getting the same denominators, okay? But we're going to look at that in a different video. If you are ready for that, check out our video on adding and subtracting unlike fractions, and then we're going to learn all about how to create and transform our fractions into equal but different looking fractions with different numbers so that we can add them and subtract them. So what is perimeter? Well, perimeter is the distance around a shape, and distance is just a one-dimensional quantity that's measured in things like centimeters, meters, inches and kilometers and all different areas of measurement.
So therefore perimeter is also a 1D quantity that's measured with these things like centimetres and inches, metres and kilometres. Let's have a look at an example. Let's have a look at a square. Now we know that a square has equal sides. So if one length is 4 centimetres, we know that all lengths must be 4 centimetres. So if we measure this, we've got 4 centimetres, add 4 centimetres, add 4 centimetres and add 4 centimetres. Gives us a grand total of 16 centimetres. That's our perimeter. It's as simple as that. All we've got to do is measure around the outside of the shape. But stop, what do I mean exactly by that? Because there are many ways of measuring around a shape. We could draw a line around the square, that's going to have one measurement, but I could draw a much bigger shape all the way around our square, and that's going to have a different measurement. So we need a rule, and the rule is that we measure the shortest possible measurement. And in all cases, that is going to be measuring the lines themselves. So in this case, 4 add 4 add 4 add 4 gives us 16. But 16 what? That's right, centimetres. The units of measurement are very important. It's not elephants or cars, it's centimetres that we're measuring in here. Could have been miles, could have been inches, or any other form of measurement, but in this case it's centimetres. And it's very important to say that because a square that's 16 centimetres in perimeter is very different to a square that's a mile or 16 miles in perimeter. Okay, so very, very important. We always put our units of measurement. We could go very wrong. So one way to think about the measurement is that we are going to be walking on the lines of our shape, and the length that we walk is our perimeter. So if we start here in this corner and I walk all the way around the square, that gives me my perimeter, okay? Or another way of looking at it is if we take one of the corners and we unravel the corner and we stretch our line out into a straight line, given it its one-dimensional property, which is why it's got the reference to the one dimension, then the length of that line is the length of our perimeter. Okay, so it's just like measuring the entire length around the shape. Great, so now we know what perimeter is. How do we measure perimeter of geometric shapes? Now some shapes like circles or hearts or clouds are going to be very difficult to measure the perimeter of because they're not straight lines, or they have areas that are not straight lines, okay? And actually in our next video we're going to be looking at how to measure the perimeter of a circle, but for now we're going to be looking at polygons. Polygons are shapes with straight lines, okay? So they're much easier to measure the perimeter, and that's where we're going to start. And it's pretty easy. If we are given the measurements of the sides, or the lengths of each side, then we can just simply add them up. Be careful to make sure that they're all in the same units, and we're not adding a metre to a centimetre or something like that. But in general, all we need to do is add it up to get to our perimeter. So let's look at a few examples. Let's have a look at this triangle with sides of 3, 4 and 5 centimetres. So in order to find the perimeter, all I'm going to do is add 3, add 4, which gives me 7, add the 5, which gives me 12. So the perimeter of this triangle is 12, that's right, don't forget it, centimetres. Very important to make sure we use that units. Now let's look at another example. Let's look at this rectangle. Now this rectangle has sides of 5 centimetres and a top and bottom length of 10 centimetres. Okay, so it doesn't matter which order we start it in because we're going to be adding them all together, and we know that addition is commutative. It doesn't matter which way around we put them. So we can start anywhere, and I'm going to choose to start with the 10s. I'm going to add my 2 10s together, which gives me 20, add my 2 5s together, which gives me 10, 20, add 10 equals 30 centimetres. Very good. Okay, cool, another example done. Let's have a little look at something a little bit harder. Let's have a look at an orange chili, okay? An orange chili challenge. So, sometimes you won't be given all the measurements, and you've got to infer and decide what you think those measurements are based on the information you've already got, okay? So let's look at that same rectangle, and let's take away some of those measurements. So if we have a top side of 10 centimetres, we know that that bottom length is also going to be, you guessed it, 10 centimetres. Okay, so we could put that in if they hadn't given it to us. And again, with the 5 centimetres, if one of the lengths is 5 centimetres, we know that the opposite length will be 5 centimetres based on the characteristics of a rectangle. Okay, so even though they weren't given to us in this example, we could infer and we could deduce those measurements ourselves using skills and using knowledge of rectangles. Okay, so that's an orange chili challenge. Now another example of an orange chili challenge, in my opinion, would be looking at regular shapes. Because regular shapes, if we know about geometry and we know about shapes already, regular shapes have 2 qualities which are the same. They're going to have the same angles and, importantly for us, they're going to have the same length side. So you might see sometimes on a test or on a question that you're given, a question where it has tell me the perimeter of this shape, for example this pentagon, which has length of 5 centimeters, but it's not giving you the other length. But it said in the question, this regular pentagon. So again, we're going to use our information of shapes and understanding what we know about the word regular, that length therefore is the same length for all the lengths on that shape. So we can use that 5 centimeters and add it to another 5 centimeters for the second line, another 5 centimeters for the third line, another 5 centimeters for the fourth line, and another 5 centimeters for the last and the fifth line. Okay, so we're going to do 5, add 5, add 5, add 5, add 5. Okay, a little bit lengthy. We could learn at this point that we could also use multiplication, because remember, multiplication is just repeated addition, which is what we just did then. We repeated the same addition. So instead of doing 5, add 5, add 5, add 5, add 5, we could simply do 5 times 5, because there's 5 lengths. Okay? Great. Let's have a look at a red chili challenge, something even harder than that. So I'm sure you've seen shapes like this. This is called an irregular shape, or a compound shape, depending on what your question is asking you. Now, problems like this come up all the time, okay? You're going to see this very often in your math and in the real world. You might have measurements that you can see, but you might have missing measurements that you cannot. So you're going to have to use the information you've already got to help solve what you don't know already. Okay, so let's have a little look at this a bit closer. Let's take these two vertical lines, and at the minute I've got a 4 and a 3 centimeters. So my missing number on the other side, it makes sense that if I just bring my two vertical lines across, then therefore that gives me that whole length. So this missing number is just the combination of the 4 and the 3. Adding 3 and 4 together gives me 7, so therefore that missing length must be 7 centimeters. Okay, so I've used that information on the other side to help me solve that missing number. Let's have a look at the horizontal. I've got a 5 and a 3. So on my horizontals, I've got 5 and a 3. If I bring them down to my missing number, so therefore that missing number is going to be again the combination of those two numbers. 5 add 3 is 8, giving me a total of 8 centimeters. So this red chili challenge is as hard as it's going to get with polygons really. We've got mixed numbers, we've got the understanding of missing numbers, we've got the understanding of what perimeter means, and we've also, as a bit of a bonus, got the understanding of we could use multiplication sometimes, rather than just adding and adding and adding if the number is the same, for example, in a regular shape. Okay, so I'm going to put some examples on the board for you here, have a little look, try and solve them. I want an answer for all 5 please in the comments section before you move on. If you get all 5, great, fantastic, move on to our next video. If you don't, stop, have a little look, go back in this video, see where you might have made a mistake and correct your errors. There's no point moving on if we're still making errors at this point. So it's really important to address them and get them ironed out right now, okay? Okay, if you got those right, that brings us to the end of the video, so well done for that. On our next video, we're going to be looking at how to work out the perimeter of circles. It's a bit challenging, so make sure we're really comfortable with this before we move on to that. So if you want to check that out, like and subscribe to the channel, guys. Thank you very much, but for now, I am gone.
What's up guys, thanks for coming back to the channel. Today we have got a brand new video. We are starting a brand new unit of work. A bit of a dreaded unit, but we should not dread it. This is a fun and exciting and interesting unit of work. We are starting our work on algebra, okay? Now, today we're going to be looking at the basics of algebra, just an introduction to it to understand what we need to learn before we can move on to solving equations and things like that, okay? So we're looking at basic algebra today and the fundamentals that we need to learn before we can explore it too much further, okay? Let's check it out. Okay, so the very first thing you need to understand is that algebra is very similar to arithmetic. It uses the same 4 operations: addition, subtraction, multiplication, and division. But algebra introduces a brand new aspect, and that is the aspect of the unknown. When you are first looking at arithmetic, the only area that's unknown is the answer. So if we look at a very basic one, 5 add 10 equals unknown. The answer is not known until we go ahead and complete our question. A very important difference straight away between arithmetic and algebra is when we have an unknown in algebra, we use a symbol, okay? Now a very common symbol to be used would be X, but you can pretty much use any letter of the alphabet. X, Y, A and B tend to be the four main ones used, but you can use any letter. So in arithmetic, we would leave it as this. 5 plus 10 equals unknown. In algebra, we would have 5 add 10 equals X. The X in this case is a placeholder and it stands for the number that we have not got the answer for yet. So what we have created is a very basic algebraic equation. An equation is just a mathematical term meaning both things are equal. Both things on either side of the equal sign are equal. So it is saying that everything on this side of the equal sign has the same value as everything on this side of the equal sign. So in this example, the equation is telling us that what's on this side, 5 add 10, the known value, has the same value as what's on this side, which is the unknown value that we are going to call X. One of the main aims in algebra is to solve equations, finding out the unknown value, in this case, X. In this example, it's pretty easy to see that we have got 15. 5 add 10 is 15. And all we need to do is add 5 to 10, gives us 15. Therefore, 15 equals X, which is the same as saying X equals 15. Now this is an extremely easy example of anything to do with algebra. And that is why when you often see algebraic equations, they are a lot harder. And you might be given a much harder example like this. If we had X minus 10 equals 5, that is the exact same equation as if we had 5 add 10 equals X. But it's not quite as easy to tell what X is. So you could look at algebra like a game. You will be given big algebraic equations that it's your job to solve, simplify and find the value of the unknown values. And we are going to learn a lot more about actually solving equations in future videos. So make sure at this point you like and subscribe to the channel to not miss that. But for now, let's learn some very important rules about how symbols can and cannot be used in equations. So the very first rule you need to know is that different symbols or different letters can be used in different problems to represent different values. So for example, in the problem we just solved, the letter X was used to represent the number 15. But X could stand for a different value in a different problem. For example, if someone asked us to solve 5 add X equals 10, the value of the X in this case is 5. Because in order for the two sides of this equation to be equal, 5 would have to add to another 5 to equal 10. So X or any other symbol can stand for different unknown values in different problems. That's fine. But what is not fine is letters cannot stand for different values in the same problem. For example, if we had the expression X add X equals 10, the equation is saying if we add X to X, we get 10. There are a lot of different ways that we can get 10 with 2 digits. We could add 9 to 1, 8 to 2, 7 to 3, and so on. But let's say we represented it as 6 add 4 equals 10. That means the first X, that value is 6. And the second X, that value is 4. This is not okay. This means that different X's would have different values through an equation. And that would become very problematic. So that's not okay. So if you did need to represent two different values in an equation at the same time, you would need to use two different symbols. And that's why we often see X and Y. So if you ever see a really long algebraic equation like this one with lots of X values, all those X values have the same value. Okay, so we know that we cannot have the same letter representing two different numbers. But what about the other way around? Can one number be represented by two letters? Yes, we can. And here's a good example. Let's say we have the equation A plus B equals 2. Now, A could have the value of 0 and B could have the value of 2. Or A could have the value of 1 and B could have the value of 1. Or A could have the value of 2 and B could have the value of 0. So in this example, even though A and B are different symbols, they are holding the same value. There will be times where they just happen to represent the same value. And that brings us on to something else that's really important. Did you notice that each symbol could be represented with a different value, depending on what the other symbol was representing? For example, if A is 0, then B has to be 2. If A is 1, then B has to be 1. And if A is 2, then B has to be 0 in order for the equation to be balanced and to be equal. So a symbol's value can change depending on what the other symbol's values are doing. And this means that it is variable. These symbols are variables. Their value can change depending on what else is happening around them. So in this example, both A and B are both variables because they can both change, their values can both change depending on what the other one is doing. So it's really common in algebra to refer to all letters and all symbols as variables. Okay, so what have we learned so far? We've learned that algebra is very similar to arithmetic. It uses the same 4 processes: addition, subtraction, multiplication, and division. But we've also learned that algebra has an unknown value that can be replaced by a symbol. And we often see X and Y and A and B being used the most. But there is one more thing that's really important I want to teach you on this video, and it has to do with multiplication. Here are the 4 basic arithmetic problems: addition, subtraction, multiplication, and division. Although in algebra, you will see division being represented in its fraction form. In arithmetic, all 4 of these operations will have the same statue. They are the same importance. However, in algebra, we have a king. Our multiplication is the king. It gets some special treatment. And that's because in algebra, multiplication is the go-to, the standard, the default operation. If you don't see a symbol, you are going to multiply. So therefore, if there are no other arithmetic processes shown between 2 symbols, we are going to multiply. So for example, instead of writing A times B, we can just write AB. And we know that multiplication is implied. Another key word for us. Of course, in this example, we can't actually multiply A and B until we know what values they are. The advantages of this is that it makes a lot of algebraic equations a lot less cluttered and a lot smaller, and you're a lot less likely to make mistakes confusing sometimes X symbol with X, the process. So for example, instead of having A times B plus X times Y, we can have AB plus XY. Now this rule doesn't just apply when it's 2 symbols, it is also implied when it's a quantity and a symbol. For example, we don't need to write 2 times X, we can just write 2X. Because there's no other process between them, we are going to imply and we are going to assume it is multiplication. However, we can't use it for just 2 numbers, 2 quantities, because if we wanted to show 2 times 5 and we move the times symbol out, it would show 25. And 25 is not the same as saying 2 times 5. So if we're putting 2 quantities together, we will still see that multiplication sign. But it will still be the case if we are using parentheses or brackets. If we see 2 pairs of brackets or 2 parentheses next to each other, without a symbol, we are going to times them. We're going to multiply the values inside each set of parentheses. For example, if we saw this with A plus B in a bracket and X plus Y in a bracket, with no other symbol between them, we know that we are multiplying the A plus B times X plus Y. So technically what we could do, going back to our 2 times 5, is we could put them in brackets, in parentheses. Therefore, this cannot be confused with the number 25, and we know because there's nothing between them that multiplication is implied. So we would times 2 times 5. Or if we wanted to, because putting 2 separate individual things in brackets does look a bit strange in maths, we could put 1 digit in parentheses and leave 1 out. Again, multiplication is implied because there's no other symbol between it, so we would still do 2 times 5. Okay, so we have learnt that algebra is very similar to arithmetic, but we have unknown values that we need to solve the equation to get to. We've also learnt that in algebra, the multiplication sign is king, and if there's no other sign there, we are going to use that as our default. Now I know what you're thinking, is algebra useful? Why am I learning this? And the answer is yes, they are hugely important. And that's very difficult to see when you're just looking at a bunch of numbers and letters on a page. But when they become very obvious and very helpful is when we start to graph these equations. For example, there is a whole group of algebraic equations that are called linear equations, and that is because they create a straight line across a graph. Those kind of equations are really helpful to tell you the slope of a ramp, or how long it's going to take to get somewhere or do something. Another class called quadratic equations can be used to design telescope lenses, or to describe a trajectory of a ball that's thrown, or predict the growth of population. So algebra is used all the time in fields like science and engineering and other forms of mathematical careers. And if you ever wanted to set up your own business, you would use algebraic equations to work out your profits and work out your potential profits. So this is a really interesting and exciting avenue of maths. Guys, thanks for watching. Check out our next video to begin solving algebraic equations. But for now, like and subscribe to this channel, please. It's really helpful. Maths Hero gone.